Good afternoon. Thank you for coming. My name is Bill Shin, and I'm a Principal Security Architect in AWS Security. I'm joined today by Hart Rossman, who's the Director of our Professional Services organization with regard to security, risk, and compliance. And we have a surprise guest speaker, Matt Breton, who's one of our senior consultants, for a little quick demo that he's going to do. So you're in architecting for end-to-end security in the enterprise. I'm privileged to have done this 4 years now in a row with Hart. And the talk has evolved every single year to give a little new perspective on what we've learned from our customers and some of our largest Fortune 500 engagements done through ProServe and through the security solution architect engagements that we do with our customers. So thanks for joining us. What to expect from this session? So we're going to talk about the practice of security architecture and how that's really evolved as people move to adopt AWS into their security programs. Just a little show of hands, who would describe themselves as a security architect in the room? Right on. So what about compliance, governance, risk people? Any people who would say they're the same? Right on. How about devs? Engineers? Cool. All right. So we'll talk about the practice and how that relates to those three different kind of disciplines. We'll give you a working criteria for end-to-end. We look back through the decks and realize we've never really defined it, so we're going to do that this time. We'll give you some translation skills. So when I talk about governance, risk, and compliance, or legal, all the way down to engineers and developers, and all the security engineers and architects in between, we find that a lot gets lost in translation. So we'll give you a methodology to do translation across those teams as applied to AWS. And you've heard this over and over again throughout reInvent, probably for a couple of years now, but the consistent theme is going to be all things as code, or all things as code light, at least, or configure. And we'll show some examples for key security controls as they're applied and implemented end-to-end according to that criteria represented by some of our largest customers. So I'm going to hand it over to Hart for a second here. There you go.
Thank you, Bill.
Yep.
When Bill and I started this talk, Mike, 3, thank you. When Bill and I started the talk about 3 years ago, we had a lot of customers asking us questions about how to document their architecture in the cloud, right? And so we took a lot of approaches. We thought, maybe end-to-end means, the beefiest, densest topological diagram we could come up with that showed every possible security product available, right? And then we thought, well, maybe customers are asking us about the panoply of security features available on the AWS platform. And if you saw the keynote yesterday with Andy, he talked about by year end, we expect to release roughly 1,000 new services and features in 2016. And I actually took a few minutes after the keynote, and I tried to count up year to date how many security services and features we've done. And by my estimation, it's about 350 in 2016 alone. And so, in our very first talk, we put up the slide and said, what we're going to do, we're going to show you the security architecture of AWS. And unfortunately, what happened was when we tried that again the second year, it became an eye chart. And by the time we got to the third year, we just couldn't depict it, right? And what we also noticed was that customers were asking, right, for architecture in a very different way. Right? They weren't asking to buy architecture. They weren't asking to draw architecture. They were asking about the framework and the mental model you can use to develop architecture in an agile way where code is how you implement it and code is how you visualize it, right? So we'll give you a little throwback Thursday, right? We're not doing that anymore. What we are going to talk about today is that mental model and a couple of different ways to think about it so that you can really develop end-to-end security architectures that are implementable in code, are maintainable in code, and can scale and flex with the nature of your business and your workloads. This past summer, so just a couple of months ago, the professional services security team published a white paper called the AWS Cloud Adoption Framework Security Perspective. And in that security perspective, we talk about, at its core, 10 security epics that over the last 400 plus enterprise security engagements we've done with our customers have been not only prevalent, but been critical success factors in those large enterprises' ability to confidently and capably move increasingly more sensitive workloads to AWS, right? And of those 10, we observed that there were 5 that every single one did. And so we talk about those as the core 5 security epics that are going to drive your architecture and your implementation, right? And they're in a particular order for a reason, which I want to share with you. In a data center, right, you procure hardware, you rack and stack it, right, and then you provision access to it. But it's the exact opposite in the cloud, right? With AWS, right, you grant entitlements within an account that allow people to provision infrastructure, right? So you have to have an approach, a mental model for how you're going to implement and iterate on your IAM architecture, right, as you grow and evolve in AWS, right? Once you have a way to provision infrastructure, you want to ensure that every single asset you deploy is under observation. So the next thing you want to think about is your detective capabilities, right? Your logging and monitoring. You want to have a strategy and a set of architectures that allow you to flexibly observe whatever it is you're deploying. Now you're ready to start thinking about that minimum security baseline for your infrastructure. How do we want to specifically configure, right, the services that we deploy? How do we want to baseline our AMIs, right, our machine images? And now that we've got infrastructure out there that we're confident in, we want to start thinking about what's our data model from a security standpoint, right? How are we going to think about encryption at rest and encryption in motion? How do we want to think about key management and secrets management? And so now what we want to do is we want to layer in, right, that data protection architecture, right, into the environment, right? And now that you've got all the critical components for a working production workload, right, you want to be able to respond to any anomalies or any changes in the environment, right? And you want to ensure that the teams that are responsible for incident management and incident response are comfortable and capable of doing their job, right, in the cloud using flexible, scalable tools within the cloud. So you want to have your incident response architecture in place. You want your workloads to be forensically ready should you need to do a deep dive and investigation, right? And so what we found is that by following this mental model, right, engagement, customer after customer, you're able to build scalable, secure architectures that are implementable in code, right, that you can iterate on over time, that gives you the operational confidence, right, and the capability through security infrastructure to be able to move increasingly more sensitive workloads, right, into the AWS environment. How does that look, right? How do we think about taking that approach to architecture and actually driving it into the organization? One of the models that we found very successful is to align that with kind of an agile DevOps approach, right? And take literally an epic, about 3 to 4 months worth of work that drives a true MVP, an initial operating capability in our environment across those 5 workloads, right? And so we've seen that in order to get into a solid set of epics, there are often 3 things that we have to do to prepare. The first is to extend the shared responsibility model from AWS and you, the customer, down into your organization and develop either a RACI model, right, who's responsible, accountable, consulted, informed, or a PDP PEP model, policy decision point and policy enforcement point model, so that you understand which DevOps teams, right, which policy managers, right, which elements of the organization are responsible for what, and you're very clear on who's contributing code where and who's responsible for decisions and enforcement along the way. The second thing you need to do is what we like to think of as security cartography, right? That's all of the mapping of your policies and procedures and controls, and Bill's going to talk about a really effective and elegant way to do that, so you're covering your architecture end to end. And then the third thing you want to do is make sure that if you have any third-party oversight mechanisms, that those are accounted for from a compliance, risk, and audit standpoint. Once you've done that, you can have your sprint zero planning, which we found is pretty effective as a security workshop, and then you can drive right into executing the architecture, right, by putting user stories in your backlog and then working through them in sprint over sprints, that by about sprint 7 or 8, you're ready to do an incident response simulation. Because remember, we've done IAM, detection, infrastructure security, data protection, right? And now we're in a situation where we've got working assets in the environment. Let's test what happens to our process and our technology when something goes bump in the night. That way we can be very, very confident that the controls and the processes are working as we intended based on the architecture that has evolved throughout the process. Right? And then the last thing we want to make sure we do is really measure our progress along the way. Right? At Amazon, we're a very metrics-driven culture, and we found that very effective DevOps teams are also very metrics-driven. And so what you want to be able to do is look at, across those epics, what are the critical success factors, the critical data elements and metrics, and not only sprint by sprint, but from start to finish, be able to evaluate the efficacy of not only the architecture, but your build and deploy model, right? And your ability to scale that across multiple workloads, multiple accounts, and multiple business units, right? And so that paper is available for you today. It's the Cloud Adoption Framework Security Perspective. It goes into a little bit more detail than I've shared with you. And it's a really good model that, again, we've seen work in hundreds and hundreds of engagements across hundreds of customers globally. Bill?
Thanks, Art. So we'll go into a little criteria for end-to-end, but before I do that, I want to point out that we did quite a bit of effort here to align the well-architected framework that Werner talked about this morning with the Cloud Adoption Framework Security Perspective. So the Security Perspective white paper that Hart talked about and that the ProServe teams use in implementations and engagements talks about the how and the practice and the sprints and the backlog. The well-architected security pillar white paper talks about the areas where some of those architecture practices or those epics use our features and services. So if you're looking to map sort of the how onto the what and the capabilities and the services and features you'd use to implement those key epics, the well-architected security paper that just recently came out does an alignment like that. So the major 4 epics, detective controls, identity, data protection, and incident response are all covered and they're aligned between those two frameworks. So definitely check those out. So what do we mean by end-to-end? Traceability has long been a common topic in software requirements going back to UML and everything else. So we don't necessarily need the formal models for this purpose with identifiers and everything else with formal requirements traceability, but it is good to have a picture of what we mean by this. So if you start at the source and if you look at what's running in your environment today, right? All the security controls and things you're responsible for operating, why are they there, right? I mean, is it best practice? Did you get owned 10 years ago and somebody put some device in place? It's probably in many cases, especially in regulated workloads, it's a contract, it's a regulatory framework, it's an industry framework like PCI. So starting on the left, your left, it's good to source where these things come from. So when the legal teams and the risk and compliance teams or the regulators come in and they say, how are you implementing this piece of wording in a contract? Or how are you implementing this particular piece or this particular control expressed in a security framework like the FFIEC examination handbook, for example? So they ask for that, right? And the engineers and the DevOps people are like, well, I got some Python code, right? So how do I get from a contract to Python code? Parsing out the controls that actually exist in those frameworks or in those contracts or those commitments is kind of the next step. And then you have control design. So when your auditors come in, they look at the design of your control to make sure it's comprehensive enough, to make sure it's actually implementing the intent and the objective of the control. And then they look at control implementation to see if your design is actually implemented. And then you have to go implement that control design. And oftentimes the engineers, particularly as things move to DevOps, they're not necessarily, they're the ones who have to implement it. But they didn't necessarily get to pick the control design. Especially in big, large financial institutions, these control designs, they don't change all the time. You have to go upstream to the external auditors or the regulators and convince them that the control design can change. So if you're moving to CI/CD pipelines, if you're moving to the cloud, if you're moving to DevOps and really fast-moving technology, sometimes you have to go back and look at the control design to see if the way you've expressed that to your stakeholders like auditors really still matches what's running in that very fast-moving environment. And then that's where we see friction. Every single time, if there's friction between the regulatory side or the GRC side and the DevOps folks, it's generally in that misunderstanding of control design. And then you look at operating effectiveness and testing, and that's the things that generally are done manually in an old data center methodology, but now they can be done in almost completely closed loop cycle using things like Lambda or config rules or just automation. You also want to have a feedback loop, right? When I mean end-to-end is that everything you learn from operating effectiveness and control testing that isn't perfect, right, and nothing's ever going to be totally perfect, and it can always get better, is you want that feedback loop to go back into your control design. So as the teams begin to implement controls, then you're getting that feedback loop. It's also important when you're going all the way from the left and talking to lawyers or regulators, and all the way on the right, talking to code ninjas, to have some translation skills. So read the source code, right? On both sides. I mean, I think the people who raise their hand and describe themselves as both GRC and security architects, like shake their hand, because they're the people who can do that, right? They're the people who can read code in this modern world of DevOps and Agile and serverless computing, and they're the people who can translate that back, and they're also the ones who are sitting down with a giant NIST control catalog and reading through it. And it's not a great read. I mean, it's awesome, but it's not the most exciting read. But they're doing both, right? And where we see people doing both, we see a lot of success and a lot of momentum as they move into the cloud. Also, Git sanity, I wish that was a method call, right? I really wish there was an API for that, where you could take a control objective and take the target environment, like an Elastic Beanstalk or a Lambda or an OpsWorks environment or an EC2 instance, and take all the way from the control objective and determine how you've implemented those controls in the actual technology. If that was a single method call, it'd be awesome, but we're not quite there yet. So don't forget to write down how you translate these things. So as you go through and you document what your controls are and how you've implemented it in the cloud, it's a very important thing to write it down. And in the old world, that was written down in static, unstructured documents, Word or stuck on a SharePoint site or something like that. And now, it would be ideal if you wrote that in Markdown and put it and check that in to a Git repository, or something like code commit. That way, the documentation of the control design that you're going to print out and give to an auditor also is in the same place where the DevOps teams are doing the real work. Because if the control design has to change, and that's in some static document stuck on a file share somewhere and printed out once a year for auditors, how are the DevOps teams going to know that that design changed? And if they do something really cool to make the control better, how do they get that feedback loop back into that document controlled by another team? So the important part is that these teams are working in the same place when it comes to the artifacts that describe your security architecture. And compliance people can code, right? I mean, we have compliance people on our security assurance team in Amazon Web Services that are coders, they're SDEs. And they automate a lot of our security assurance that goes into our SOC 2 report, our ISO 27001 framework, our PCI certification. And likewise, coders can, if they're interested, they can read the control frameworks, right? Pick up NIST, pick up PCI, pick up a SOC 2, and take a look and see what the audit community is using and what they expect. Or just get a beer together, right? I mean, get like the DevOps teams and the auditors and legal folks to just, hang out a little bit more. So I'm going to turn it over to Hart. Talk a little bit about, actually no, I'm going to stick with this one. So identity access management, it's kind of that first epic, and we'll go through an example of how we take a control all the way sort of to end to end. So this is kind of an abbreviated, because it's a lot of text, in NIST 853, has the access control family. This is something that everybody probably encounters, where you have control AC2 in NIST. It's account management, and it just describes what the organization has to do. They have to assign, I won't read the whole thing, but assign account managers for information system accounts. Specify authorized users in the information system, group and role membership, but there's like hundreds of controls in NIST, right? This is just one example. So one of the techniques that we find very successful when we help customers understand how to translate these kind of controls into real running automated technology is to look at all the maker words, if you will. So if this is a control documentation, what do I have to do as an engineer to get this thing done? So pull out all the maker words. And I kind of like to break it down a little more into just nouns and verbs, right? What do I have to do? Who are the people or the principles or the things I have to do something to? And what are the processes or the verbs that I have to go implement? So in the previous example, I have to assign account managers. I have to establish group and role membership. And that means that the verbs are what you're going to automate in almost every single case where you can. You want to be looking at the verbs in those controls to say, this is now code. And however I can take that verb from that control and code it up, it's one less thing that humans have to do. It means there's much less opportunity for mistakes. It's much, much easier to measure. So you're measuring around the verbs, and you're assessing and attesting to the effectiveness of the controls where the nouns are related. So I think it's a cool methodology. We've seen it work. Let's take an example. So if you look at AC2, the source is like a federal contract or the FFIC examination guide, which is loosely based on 853, or the HIPAA security rule, which has alignment too. Down into AC2 as a control, and then if you want to look at the control design, that might be written up in a README doc, written in Markdown, checked into GitHub, or to code commit or your source code repository. The control implementation might vary, right? It's going to be something where you've taken your roles for identity and access management, and you've checked them into Git as JSON structures, and then you're using something like a build pipeline, like a Jenkins task or code pipeline, or code build now, to go and push those identity and access management JSON policies into the API for IAM, right? And so we have versions in IAM too. So if you're using the console, there's versions in there. But if you're doing this at scale, a lot of companies are using the JSON structures that define the authorizations and entitlements that would give you AC2. They're storing those in source code, and they're pushing those as they update them with version control based on an access request in a ticketing system or a pull request or something to go and update the live running environment in IAM. And they use automation tools to do that. And then from an operating effectiveness perspective, you use CloudTrail and you use config to detect change. When any of those entitlements change on the IAM side, you'll know about it, and then you give that feedback loop to say, why is this change out of band? Did someone change it through the approved, trusted pipeline, or did they do it out of band through the CLI or the console or something like that? So I'm going to get Matt up here, and or maybe Art? Yeah.
So when we start talking around this cross-account federation, it becomes a little complicated, especially when you have multiple accounts if you're trying to do everything manually. So what we want to talk about is another framework that allows us to actually allow the organization to control what roles and privileges that these individuals have across these accounts, while still ensuring that we're able to provision this dynamically using Active Directory and other IDP as well. So what we see here is an architecture that allows an individual to log into a portal. This could be single sign-on, it could be your internal identity provider, so therefore the users themselves don't have to know another credential for AWS as well. From there, we're going to maintain a database around how these users are actually allowed to access the individual accounts. So within this database, we're going to allow for the roles that they're allowed to assume, the accounts that they're allowed access to, as well as an external ID that allows us to have the security around the assume role functionality from the security account. More than that, though, we're also going to start capturing metadata around these accounts as well. So now we're going to start capturing what is this account actually containing. Is it a production account? Is it a development account? From there, we're able to make risk-based decisions when we start looking at it from a continuous assurance perspective. Additionally, we're also able to capture the data that's maintained within that account. Is it PCI data? Is it HIPAA data? Is it customer data? Again, this is able to be rolled into our risk-based decisions. So when it comes to actually respond to an incident or generate tickets off of this, we're able to seamlessly do so with having the understanding around the data that's actually within that account. From there, from the user perspective, they see a portal. The portal is very clean, it's able to be scaled, but more importantly, allows them to be able to assume the roles within the individual accounts that they need access to. So if we dive in a little deeper, this is what it actually looks like from a service perspective. You have an account management console that allows the owners of accounts to onboard existing accounts into this framework, as well as allowing new accounts to be provisioned using the new organizations API that was just announced. From a federated user standpoint, they're able to access this console using your identity that they already know and love, their corporate credentials. From there, we have the actual service itself. From here, we have a number of workflows that are generated off of this. It ties, as I said, into your existing identity provider, as well as into AWS to allow us for this assume role functionality between your accounts. More importantly, though, it also ties into a database. This database, as I said, contains this metadata, but also contains the log events of every action that's being performed within this framework. So for example, if a data categorization within an account is changed from no sensitive information to sensitive information or vice versa, we're able to log that information and then drive tickets off of it. So from an incident perspective, if someone changes a account that contains PCI or HIPAA data to no data, we would want to understand why that change is being occurring. Additionally, if someone leaves your organization, we want to be able to have a workflow to ensure that we have a clear identifier around who's the owner of that account. From there, this is what the auditor is doing. It allows us to be able to monitor this workflow and ensure that it's constantly updated. But it also, more importantly, this system ties into your existing ticketing system. Now, to be clear, it needs to have an API and there's some limitations. But what this allows it to do is actually act as a force multiplier for your organization. So now what we're able to see is as users are logging in, we're tracking that. It's also being tracked in CloudTrail. But now we're also able to dynamically create tickets. So in the example I mentioned before, where an individual leaves or changes roles within your firm, you're able to dynamically create a ticket, to then move the secondary owner to the primary owner, and then the secondary owner has to assign a new owner as well. So therefore, you always have an individual that you could go to when you have questions or if there's an event. So what does this actually look like from an example perspective? We could show, let's fix it. Again, this is a simple example. This is, again, based upon what kind of AWS uses internally, as well as something that professional services has offered and is built out for EndtoEnd as well, and help them actually manage their new accounts. So what you get is this simple portal. From here, you're able to see the existing accounts that you've been provisioned for, as well as the individual roles that you have access to within the account. Since this is driven from, in this case, Active Directory, you could create AD groups based upon this as well. So the AD group could be assigned an individual account number, followed by the role that they're able to access within that account. Now it is easy to grant new users access to these individual roles. But to onboard, for example, you're able to capture this information. This is the metadata I was talking to you about earlier. So here, when you're onboarding a new account, you're able to capture that data classification. Here we're asking, is there customer data? Does it have PCI data, HIPAA data? Again, to make risk-based decisions later, as well as the data environment as well. To onboard an account is relatively simple. Again, you input an IAM credential. We're not asking for a root credential. This credential isn't being stored within the framework at all, but we're using it to actually provision 2 other roles within the account that you're onboarding. A mascot role, which is what we're calling this as the professional services offering, that allows us to then assume roles and manipulate IAM policies within that account. But we're also going to be provisioning a security auditor role as well. This allows us to actually do describe role calls within your account within this framework so that we understand what's actually going as your security organization. We're capturing the owner of the account, myself in this case, as well as the account description so we can make decisions on that as well. When it comes to managing policies, we're also able to do that through manage policy templates. Here you're able to see the policy templates that have already been provisioned within your organization, as well as create new policy templates. So for example, if we wanted to create a new policy, we create one here. We could call this deny, and we're going to create the, and we're going to put it in a new policy statement. We could add it. And within here, we see that a new policy has been created with me as the owner of that policy. We could then go to the roles section. We see the existing roles that I've been authorized to see within this. If I want to add a new role, I click a role, name that role, and then pick the policy that I've been authorized to select from. Again, this is great because similar to how AWS has their managed policies, you as an organization are now able to have your own managed policies that you allow your users to select from to ensure that they're not granting themselves additional privileges or anything else. Select add. We've now created a role within this mascot framework. We see it right over here. This doesn't dynamically be deployed to anywhere until you select so. And you have to have the right authorization to do so as well. So when you select deploy, you see a list of the accounts. Myself, I'm only allowed to have access to one account to actually deploy roles. So I select deploy that role to that account. When we go back here now, we now see I now have this new role deployed within this account. And from a role access perspective, it grants your users the ability to access those roles as well. So if I click on this full admin role that I've been granted to, one-click access into the AWS console. Again, notice up here on the top right, you actually see that it still captures my identity. So from a CloudTrail perspective, this is still being captured within CloudTrail, and it has an easy way to actually follow through from the mascot console to the AWS console who's actually using your services in the flow. But also, for users that want to have direct STS to access, we also have that ability within this as well. So I created this deny role policy before and applied it to this account. So within this, I'm actually able to show this STS tokens. Again, I created the deny role because I don't trust any of you. I don't want you copying this and deploying it because this is a live credential at this point that has absolutely no privilege. But now users are able to actually copy this into their CLI if it was an actual credential that they could use and use it within their day-to-day activities. More importantly, since this is just a skin in front of APIs, you could actually tie your CLI or SDKs and wrap those and dynamically call for this credential, which moves your users from having to deal with long-term credentials into short-term managed credentials, all managed within this framework. Again, this is just a framework. So what we're recommending is that you could build this yourself. This isn't an offering from AWS, but if you need help, this is something where professional services could definitely help you and integrate this with your existing identity service as well as your ticketing service for that full integration.
Thanks, Matt. Oh no, you logged me out. So what we did there was show kind of the end-to-end, right? So you go from control to control design, and you go all the way from like something like NIST AC2 all the way into a system like that that implements the IAM for the organization. So we'll talk a little bit about detective controls too and do a quick translation. And then Hart will talk about an actual running implementation we've done for some other customers. So NIST 853, right, AU6, it says you should audit some stuff. If you take out the maker words, you got to review and analyze the audit records and report findings, right? So what does that mean, when you actually go and implement it? It probably means something like aggregate all the terabytes and petabytes of logs that are generated in your hyperscaled environment and stick them into a big processor and then send it to the ticketing system so security operators can take action. That's really what somebody has to go implement, and that's a lot of work. So it is important to have that traceability and know which services you're using to implement things, what the data flow looks like, and then have that documented somewhere. But getting that end-to-end, it comes from the AU6. You have the control objective that's documented, your nouns and your verbs. You do the control design, and that's written up in a Git repository. And then you use, AWS services or services higher up the stack in the operating system, something like, at the Amazon layer, though, it's things like VPC flow logs, it's things like CloudTrail, and sending those into CloudWatch logs and using Kinesis streams to get into something like Splunk, or use it, put it into a streaming architecture on EMR, and then from there you can take that data and the result sets and take actionable events or indicators of compromise and send those to your ticketing system, send them to your Slack channel, send them to an operator through SNS. However you want to notify people, you've already done the processing, right? But that's the power of the cloud, is that you can take so much of this data and implement a very vague, fairly vague high-level control like AU6 and say, we've done this, we've documented it, and now it's probably going to be a CloudFormation template too, because you can orchestrate how CloudTrail's configured, you can orchestrate how config rules are done, you can orchestrate the Lambda functions, you can do a lot of that stuff using source code-based solutions, and that source code for how you implement those things, if you do it in CloudFormation, like VPC flow logs, for example, you can turn that on and capture that in a way that's now in a source code repository. If you look at, if you want to know that you're logging from all the right subnets and all the right security groups, and all the right, security groups that would show up in VPC flow logs, you can have all of that in CloudFormation templates. You're not going out to routers and switches and firewalls and printing out, the configs. You're actually doing it in a source repo, and so every time one of those configurations change, it might affect your controlled effectiveness because it's turning on or off logging. So if you capture it in source code, you have the full version and the full diff and all the commits with the comments and everything else, and that's the change control for your control that implements the logging and monitoring. And so end-to-end, it's auditable and traceable, and you're able to prove, the control design works. Yeah. So Hart, I'm going to give an example.
Sure thing. Cool. Thank you, Bill. So one of the things we often talk about with customers is to make sure that, again, we started with the philosophy when we talk about IAM, and the next one is detective controls and logging and monitoring. And when we start to talk to customers about that, we often focus on the basics, right? Make sure you have CloudTrail turned on in all accounts in all regions. Make sure you have VPC flow logs turned on. Right, suck in security relevant telemetry from services, and if it's a service where the shared responsibility model is shifted a little bit like RDS, and we're also managing, for instance, a database for you, make sure you're getting those application level logs as well. So in that case, right, you've got 4 sets of logs to look at, and then we'll often start talking about, well, let's look at things like, blast radius. So we want to know every time an internet gateway is turned up or down. We want to know any time that CloudTrail is turned on or off, right? But as you start to dig into the logging, you start to ask questions that perhaps your SIM can't easily instrument for, or perhaps a simple binary, is it up or down, right, isn't really going to answer the mail. And we had one customer come to us and say, it would be really interesting if we could use VPC flow logs to detect beaconing from potential malware or misbehaving instances, right, over HTTP or DNS. And they started down the path of using a SIEM and working through it, and they got some really basic analytics done. They said, we feel like we're missing some of the beaconing behavior. Do you have another suggestion? And we said, well, gosh, yeah, we've got a suggestion. Let's use the big data analytics tools on the platform that other customers are using for genomic sequencing and clickstream analytics and all that other fancy stuff, and let's apply it to some security analytics, right? Let's look at a series of data that can be sporadic or sometimes consistent, and let's see if we can identify those beacons at not only higher fidelity, but faster than we might do with some alternative means, right? And so we did 2 experiments, which I'll call MVP, right, to get that minimal viable product, and then our second iteration. And so if you take the sprint idea I suggested earlier, this was in fact a 4-week project, right? We did 2 sprints, each of 2 weeks. The bulk of the time was actually spent generating data and looking at the data science, not managing the infrastructure, not standing it up, right? And so I'll just sort of briefly walk you through the architecture. On your left side of it, we have the ingest, and we have 2 ingest points. The first is we wrote a couple of Lambda functions that collect metadata from EC2 that we were interested in to provide context about the flows that we wanted to analyze. And then we used Amazon Kinesis Firehose to ingest the VPC flow logs themselves, right, and to organize them a bit for us, all into an S3 bucket. From there, we ran a series of EMR jobs with Spark, 20-minute batches, to do some initial analytics. And what we decided to do, based on the expected behavior of the beaconing, we didn't know for sure what it would look like, but we thought k-mean clustering would be the right analytic approach to start to look for potential beacons. And the reason we thought about that was because the nice thing about k-mean clustering is that as you see more behavior over time, like tends to cluster with like, and it spreads out the difference between clusters, so it becomes very clear very quickly where there's affinity groups and where there's outliers, right? You can do it very, very rapidly. So we used this approach with the enriched data, right, in the center, to go ahead and run these 20-minute batch queries, and then we used CloudWatch alarms along with an analytic notebook tool to go ahead and alert anytime there was a substantive change in the clustering model, right? So whenever we thought something that was becoming a sufficient enough outlier that it looked like a beacon, right? And this was a really effective mechanism to detect beacons, it turned out. And we found a lot of both consistently beaconing and inconsistently beaconing instances. Some of that was traffic we generated, and some of it was traffic that some known malware generates, and that was kind of cool. Then we said, can we do it faster? 20 minutes is pretty darn fast, but you can also exfiltrate a fair amount of data in 20 minutes, right? So we said, can we do it even quicker? So the second iteration, we focused on doing this instead of 20-minute batch processing, strictly through a streaming mechanism, right? And instead of archiving so much data to provide support for us to do some research and analytics, we said we just want to get to the result. We want to know if something is beaconing or not. And we want to do some daily training and scoring so that it gets smarter over time, right? And so we used fundamentally the same approach, but what we ended up doing is having a series of smaller Spark jobs, right, that allowed us to do actions much quicker and have that feedback mechanism that Bill was talking about, right? So that the system gets smarter over time and allows us to alarm on cluster changes much more rapidly. Right. Bill?
Yeah. So if we look at the cloud adoption framework, or well-architected, there's portions of that related to the security pillar has infrastructure security. And that typically means things like server hardening, vulnerability assessment, scanning, the things that are not logging and monitoring or identity or data protection. So lots of the DLP type solutions, anything you'd consider sort of in that category of protecting your infrastructure. The thing we're also starting to see a trend here during this talk is that there isn't one unifying security architecture to rule them all, right? The architecture exists at the control level. So it's very important to have the implemented technology trace back to those controls, and that becomes, each line that we're showing with that loop on the end is an architecture itself So and collectively, you could put those together and have your grand security architecture. But that means you can be agile. It means you can iterate and have small batch deployments for security too, because you just kind of swap them out. If you don't want to use one implementation, you don't want to use Spark, you want to use something else, then you just have to change that one piece of the architecture. And then it becomes very iterative and loosely coupled, and you end up with a bunch of security microservices or security mini architectures aligned to each control. But then you can map it back. So configuration management, that's a beast, right? I mean, that's a long paragraph that, a lot of security implementation people who do, AMI factories or patching or server builds just probably haven't read. Basically, it means, harden your stuff, have a configuration you develop and document. So you take out the maker words, right? Just, go find all the words where you got to do something. And you have nouns, right? Documented sets of specifications. That's what it kind of boils down to. And depending on where you are in the stack, if you're on networks, it's probably route tables, firewall rules, load balancer policies, subnet allocation. In operating systems, it's versions and dependencies. In applications, it's your code. It's your configuration files. It's your dependencies and your libraries. So that's a lot, right? I mean, configuration management's a big, big space. So how do you do that? It's probably not even going to be one source code repository. It's going to be a bunch of them. One for your AMI bakery or your AMI factory where you build your images. And you use your Packer configuration or something like that, or you use your scripts that you pass into EC2 user data to build and configure the image. Up in the application space, it might be just a bunch of Lambda functions checked into a source code repository and deployed through a pipeline. But that's where your configuration exists, and that's how you implement that control. So the control objective of document your stuff, get the nouns right, that's going to be the code. And in almost every case where Hart's talking about these streaming architectures, you can put that in code too with CloudFormation or other means. But when we talk about infrastructure security, it's a lot. So being clear about what the nouns are, and everybody understands where's the line, what do you document, what do you make a specification for, and if that's a standard that's written every year and given to the audit committee, that's going to change more often than that. You've got to iterate more quickly. So you look at the verbs, they're formally reviewed and agreed upon. So what does that mean? And I think in many organizations for a very long time, you had a committee or a working group that would review and approve the standards, right? But then that's just not fast enough, right? Security has got to be the fastest thing in the company. If the standards, if some new threat or vulnerability or new application framework that people want to use, or you do an acquisition, you've got to be very fast, and you can't go update the standards. That can't be an annual function. It's got to be something that lives and exists with the technologies you're acquiring as you acquire them. So formal, in this case, in this methodology where everything's code, formal means the Git comment when you commit. It means the pull request. It means that you have different people who can commit code, who can approve the code to get built in a build library or a CI/CD pipeline and push the button to make it go into production. And so you have split access, you've got formal approval, you have a management chain around that, maybe it's a ticketing system, but they have to be the same system, right, and the same workflow. So, some of the verbs, right, it might be a change ticket, you might implement that through a service request. You could probably do it, a master image build task or a Jenkins task, some kind of code commit. But notice the verbs at every part of the stack now, they're all code. And I think that becomes the artifact, becomes your audit evidence. To look at an example of just doing this with a base image, you could do this with just take an EC2 image, for example. However you want to configure that EC2 image or that Docker image or that Lambda function, whatever compute function you want to do, you can check all the configuration of that image into source code. So all the etc files, all the libraries you want to pull down. If you want to pull different packages with Yum or something like that, you can document that in source code too and just execute it as a script with user data or CloudFormation or Puppet or Chef or any of these automation frameworks. But all those are conducive to source code. And then you monitor that control using config, using logging, using CloudTrail. Every time a new image is launched, every time a new EC2 instance is launched, did it use the approved AMI? You'll know that in CloudTrail, and you can reconcile that through log analysis. So just depicting this real quick, your control design can be, in this case, CloudFormation, right? Or something like Elastic Beanstalk, or anything that configures the running environment that you can express in a configuration file or a piece of source code becomes that control design. So when someone goes and audits it and they look at how are you implementing this control that's really just a paragraph of text, the new audit artifact is going to be that source code. And so that might require a little auditor training and a little bit of narrative around it to explain how the process works, but then it's all automated from there. So you can use code commit, or you can use a Git-based repo, and then For control implementation, it's something like Code Pipeline or a Jenkins build task that takes that CloudFormation template, executes it, and pushes it into the running environment. So the entire VPC, the subnets, the firewall rules or security groups, the route tables, anything that you could express in CloudFormation becomes now a running, living VPC. Same thing for the, as you move up the stack, the parameter groups for RDS, API gateway, any API functions can be expressed, Lambda functions can be committed the same way. So, and then to test the operating effectiveness, anytime some of this stuff changes, you're going to know if it changed out of the approved CI/CD pipeline. So there's lots of talks today, or reInvent in general, about trusting your CI/CD pipeline, building that kind of workflow on top of AWS, and they're very geared toward developers, but for security practitioners too. All of your security controls and tools that you're familiar with can almost entirely be implemented in some sort of configuration-based or code-based repository. So we're going to open up to a little Q&A, and thank you very much.